Take a network break. I'm Drew Conry Murray.
I'm Jonna Johnson.
And as we slide into the end of summer, help yourself to a virtual donut, and let's hop into the wobbly wave pool of this week's network and IT news. We're going to cover a red alert from the FBI, some quantum news from Palo Alto Networks, IPv6 coming for DNS, some updates from NetBox and Lumen, and more. We're sponsored today by Do It. Cloud isn't just a cost center, it's your growth engine. Do It Cloud Intelligence aligns every dollar with your business intent, surfaces hidden inefficiencies, and turns alerts into engineering-ready tasks. CUI teams are 10x more likely to hit business outcomes. Visit doit.com, that's doit.com, to unlock intent-aware FinOps. And after the news, stay tuned for a Tech Bytes podcast with sponsor Palo Alto Networks. We're going to talk about Palo Alto Networks' Advanced DNS Resolver, or ADNSR, which provides a security-centric, cloud-delivered DNS resolution service. We get details on how ADNSR works, its features and capabilities, and how it differs from other DNS offerings. Jonna, I know you usually lead the red alerts, but I found one and you said, yeah, put this at the top, so I hope you don't mind me going first.
Please do. I just want to highlight that this is also a CVE.
Okay, great. So the U.S. Federal Bureau of Investigation, the FBI, is warning that Russian state hackers are targeting end-of-life Cisco devices running iOS and iOS-XE software. The hackers are exploiting a 7-year-old vulnerability for which a patch has been available. The vulnerability in question is CVE 2018-0701 with a CVSS score of 9.8. Now, the FBI says it has detected attackers collecting config files for, quote, thousands of networking devices associated with U.S. entities across critical infrastructure sectors. In addition to the FBI talking about this, there's also a blog from Cisco Talos, that's their threat research arm, saying that those sectors include telecom, manufacturing, and higher education in the U.S. and globally. These hackers, in addition to getting configs, are also establishing persistent access. So the vulnerabilities in a smart install feature in Cisco iOS, it lets an unauthenticated attacker trigger a reload of the device using a specially crafted smart install message. The reload can either cause a DOS condition or let the attacker execute arbitrary code. John, as I mentioned, Cisco released a patch for this vulnerability 7 years ago, but apparently there are enough active devices still operating in the wild in critical infrastructure so that the FBI and Cisco felt compelled to issue a warning. Any thoughts here?
Yeah, I think the big thought is if you are a network administrator or a cybersecurity person in an organization, do expect your boss, your senior execs to come and thump you on the head on this, because it's gotten a ton of coverage in the regular mainstream press because of the Russian state angle, which I find is hilarious because basically pretty much all of the vulnerabilities are getting exploited by either Russia, China, North Korea, or Iran. So it's like, really, why is this different? But be that as it may, expect a lot of airplane reading syndrome where people are going to come in and say, has this been hacked? Has this been patched? Did you patch it? And why not? So, the actions one should take hearing about this are, number one, validate that in fact you did patch it. If not, patch it really fast, because you're going to hear about it from people who don't normally come chasing after you. And number three, if you happen to be in the business of trying to make a case for automation and particularly automated patching, this is an excellent piece of ammunition. So, what's that great Donald Rumsfeld quote? Never let a crisis go to waste. Mm-hmm. This is a perfect time to say, hey, boss, it was patched, but in order to ensure that this never gets us unawares in the future, that $50,000 investment that's been sitting on your desk for the past 18 months, can you please sign off on that so we can fix it? I'm really not kidding. There are a lot of people that are still relying on manual or semi-manual processes. If you haven't sat down and thought about how to automate your patching, you should do that now. If you have and have bought automated patching, then this doesn't apply to you because you already got patched. And if you have yet to get over that final hump of getting funding approval and purchasing approval, this is a great time to push.
Yeah, what jumps out to me is the fact that these attackers are getting so much mileage out of a 7-year-old vulnerability tells me two things. First, it seems like there are organizations, I'm assuming telecom and higher ed in particular, who don't have visibility into or the operational capacity for vulnerability management and remediation. That's a problem.
That's the automated patch. Unfortunately, there've got to be a lot of people who aren't deploying this right now, and they should be.
The thing is, though, automated patching sounds good, but there are times when a patch could have unintended consequences, and if it brings down a production equipment and you get yelled at or fired because you lost some money for that outage, this is
Don't do it that way. I mean, I configure it. I mean, I'm serious. Use your common sense.
Sure.
Buy a product that you can configure to do proof of concept, kind of soft rollout, then hard rollout after the testing happens. You can build that in around the edges. I'm not trying to minimize the effort involved in doing intelligent automated patch management, but this needs to be an area of focus because you can't sit there and wait for the Russians to hack your network and then go, oops.
Absolutely. I think the second reason is network engineers and infrastructure operators are bombarded with vulnerabilities, with patching, with remediation, with workarounds, and all of their software providers, all of their vendors face no repercussions for shipping buggy, crappy hardware. The burden falls entirely on the customer, and I feel like at some point that's got to change because a 7-year-old vulnerability should not be prompting 7 years on an emergency notice from the FBI.
Well, yes and no. And I mean, that becomes a bit of a philosophical debate that you can run into. I mean, if you look at cars, basically all a car manufacturer has to do is say, oh, hey, by the way, we have a recall notice, bring your car in and we'll fix it. I don't see anything beyond that, and it still requires action on the part of the consumer. The problem is if I'm a vendor and you put me in the position of you must make sure your code is always patched and always kept to a standard once it is delivered to the consumer, my response is cool. Then I need all possible control over the consumer systems because that's the only way I can do it. And flipping my other hat as a consumer, I sure as hell don't want to give Cisco unlimited control over my routers for all sorts of reasons. It's bad enough that they have some degree. So the problem is I don't know, you can sort of hand wave and say, oh, gee, the vendors need to be held responsible in some way, shape, or form. But the only way a vendor would intelligently assume that responsibility is by assuming the concomitant control, and no sane network engineer is going to give them that control, except in limited bites, like you've outsourced the management of your network. Okay, fine. So that's the squaring the circle problem we run into.
Yeah, I get that. I just feel like this has been such a persistent problem for so long that the status quo is just not tenable, and it keeps biting us in the behind, and we need to figure out a different way to approach this.
I couldn't disagree, but I'm not sure there's an easy answer.
No, there isn't, because otherwise it would have been done. So yeah, let's move on to our next red alert.
We do have lots of good show notes, by the way. Go read up on them. And again, be prepared for your boss to come tap you on the shoulder on this one. Unlike the one we're about to talk about, which is also an example of still lurking vulnerabilities. In other news, according to CVE 2024-3094, the XZ backdoor vulnerability is still lurking in Docker images. Wait a minute, this is sounding really, really similar. There's a vulnerability, in this case it's only a couple of years old, but it's still an older vulnerability. The XZ backdoor, it's actually a pretty big one, and we talked about it extensively, is a corrupt version of the XZ compression utility that allows root-level remote code execution on affected systems, among other things. It was the culmination of a multi-year effort to compromise the maintenance process for the XZ Utils code, which is used in a huge percentage of Linux distros and other Unix-like platforms. It was discovered by accident only shortly before it was going to go into a very wide distribution by a sysadmin, not a cybersecurity professional, trying to identify the source of a slowdown on a new system build. And I think we spent some time last year talking about exactly what this was and how fortuitous it was. But this heroic sysadmin ensured that it was exposed and rooted out before it had gotten past some experimental Debian distros and similar. It's back in the news because a new reservoir of the corrupted code has been discovered, Docker Hub. Binary Research reports that it has found base images in Docker Hub infected with backdoor and also images built based on those infected images. The fix is, wait for it, use unaffected Docker container images. Go check out the show notes for where they are. But, yet another reminder that these vulnerabilities can lurk for much longer than it takes us to announce them on network break.
Now, you said this was a culmination of a multi-year effort to compromise this software. So it sounds like this was maybe a group taking advantage of some open source processes to insert malicious software into a widely used tool.
Yes, and I am relying on I'm relying on memory now, but like most of these serious attempts, I believe it was a nation state attack, or I forget which one. But again, most of them are nation states, the ones that put all that kind of effort into it. But yes, that's the kind of thing that that's the world we live in, guys. Sorry.
Yeah. All right, moving on to some news. We'll start with Palo Alto Networks. They've announced a bunch of new capabilities to help customers prepare for quantum security readiness. There's a few here, so bear with me. First, Palo Alto Networks says its Strata Cloud Manager is going to offer a quantum readiness dashboard. This is meant to help you assess whether your Palo Alto next-gen firewalls and SASE deployments are quantum ready. The dashboard has 3 capabilities. It can provide inventory and assess the cryptography you're using as secure, weak, or vulnerable. It can validate regulatory and standards compliance, and it supposedly can help you upgrade to post-quantum cryptography using an inline workflow. Second, Palo Alto Networks says the latest version of its PAN-OS operating system, this is the 12.1 Orion release, now supports multiple NIST standards for post-quantum encryption. The company is also claiming Orion provides quantum-safe site-to-site VPN tunnels and TLS sessions. Third, the company is introducing hardware-optimized firewall models in its 5th-gen release, including the PA5500 with the, quote, 256 cores of compute and hardware acceleration to process encryption at scale, end quote. That also includes the FE400 ASIC in this model for packet processing. Lastly, the company says PAN-OS 12.1 supports a standard for quantum key distribution. Quantum key distribution uses elements of quantum mechanics to secure key exchange and also should be able to detect eavesdropping during that exchange. The standard is ESTSI 014. It specifies a key delivery API. It's designed to promote vendor and application interoperability in quantum key distribution. So, Jana, I know you and I are keeping our eye on the quantum market, and I'm always curious to see what security vendors are doing with the NIST algorithms and so on. So just want to keep folks updated. Do you have any thoughts here?
I do. I mean, this is definitely a good move. It's table stakes. The only thing that rubs me wrong on this is that they call it quantum security innovations. There's nothing innovative about this. Sorry, quantum key distribution has been around for a while. Having a dashboard that says we can tell you whether our stuff is secure is nice, but it's hardly innovative. And supporting existing standards for post-quantum encryption, again, good thing to do, not innovative. So my only bone to pick here is not with Palo Alto, the company, but maybe, hey, guys, in your PR department, scale it down a little bit. Palo Alto continues pushing forward with quantum readiness is fine. Innovations is going a bit much.
That is a battle I have been fighting with PR and marketing departments probably my entire career. So, good luck to us.
Right. Well, the only thing I would tell you, PR and marketing departments, is that the reaction of your typical techie when seeing slightly hyperbolic stuff is to view your entire announcement as complete BS because it's a little bit hyperbolic, which is exactly the opposite of normal humans, I admit and acknowledge. I just want to point that out.
No, I think you're absolutely right. And that's why I think it's in their best interest to temp it down a little bit.
Exactly. And I've been guilty of it myself. Somebody once, thumped me on the head recently saying, a one of its kind. Well, it's not really one of its kind. And that verbiage is actually off-putting. So.
I guess we are all guilty.
Okay. We are. Moving right along, IPv4 is getting yet another nudge out the door from the IETF, which is now pushing harder on v6 as best practice for NextGT DNS. Momoka Yamamoto of the WIDE project, which is a research consortium that works on internet technology and standards, and Tobias Fiebig, I believe, of the Max Planck Institute for Informatik, drafted a new set of DNS IPv6 operational guidelines for the IETF. They intend this draft proposal to replace the current one, which is RFC 3901, which only requires authoritative or recursive DNS resolvers to implement v4. V6 is actually left optional for those authoritative and recursive resolvers. Mm-hmm. So kind of interesting. The authors note that DNS resolvers are still relying on v4 because, adoption has been slow to IPv6 since the 1990s. Drew, I promised you I would spare you my rant. So all I can say is back in the 1990s, I was working in the IETF and working on a lot of this stuff and advised the IPv6 bigots at the time that it was going to be a long, slow transition, and they told me I was nuts. I would just like to encourage everybody to look at the calendar and say, we're still transitioning DNS over to v6, and it's 2025. That's a quarter of a century after I said those things or more.
We were just talking about language, and you said IPv6 bigots, so I can imagine flares going up now.
Yes, of course. But let me be clear that anyone that's working on IPv6 now is not necessarily a bigot. I will say certain members of the the IETF were in fact bigots because they explicitly said we are going to push this protocol through without really, while knowing it doesn't resolve some of the problems that it could resolve if we worked a little harder and a little longer on it, because we are terrified that the internet is going to run out of address space by the year 2000 and we're going to look bad. That is a direct quote. So that is a bigot. Sorry. Everyone who's been working on it since then, you're off the hook. So just to clarify.
So just some comments from me. So this is just, it's not a requirement yet, is it? It's a suggestion. Yes, they're proposing this to the IETF to see if they can get it put through.
Well, no, it's a draft spec which basically says, oh, hey, let's change this, V6 support from optional to required. Mm-hmm. Keep in mind that there are no IETF police. They're not going to come after you if you do it.
Sure.
It's just, it seems like it's perfectly logical, and the authors really kind of point out that it shouldn't even have to be said, and I would agree with that.
Yeah, when I saw this, I was like, wait, what? There are DNS resolver services that aren't IPv6 enabled, or at least dual stack? That seems crazy.
That is basically, I think what they're trying to do is shed a spotlight on this. So basically, I don't know that there's anything actionable here other than, you feel free to write agitated emails or post agitated things to packetpushers.net/follow-up if you're mad at me for calling people IPv6 bigots. But, if you happen to be operating one of those DNSs, fix it. And you should have done so years ago, even back when it was still optional to support V6.
Yeah, for sure. All right, links in the show notes. We'll move on. NetBox Labs, they sell source of truth software for network operations. They've announced a sneak peek at a forthcoming feature they're calling NetBox Analytics. The intention is to take the data that NetBox has about your network infrastructure and use it to do things like visualize your network topology and site redundancy, track IP address utilization, understand issues around rack density and power usage, and do some capacity planning. NetBox says it's opening the analytics feature to NetBox customers who want to see the early prototypes or offer feedback or suggest use cases. There's a link in the show notes if you are interested in this and want to sign up. NetBox says the full product should be available in the coming months. Comments, Jonna?
Just sounds good to me.
Okay. We'll leave it there. A quick break to tell you about our sponsor, DoIT. Cloud spend is just the surface. What really matters is how it drives your performance, reliability, and speed to market. DoIT Cloud Intelligence aligns every dollar to the intent of the workloads. It helps teams go beyond dashboards, surfacing hidden inefficiencies, resolving incidents faster, and aligning cloud operations with your business priorities. One platform, unified signals, better outcomes across engineering finance. Visit doit.com, that's DOIT.com, to unlock intent-aware FinOps at scale with DoIT Cloud Intelligence. We thank DoIT for being a sponsor.
Yes, thank you for being a sponsor and also for having a really cool name, guys. Okay, moving on to nation-state actors. China crippled access to the global internet briefly on Wednesday, August 20th. For reasons not yet disclosed, China's so-called Great Firewall cut China off from most of the global internet on Wednesday. Censorship activist group Great Firewall reported on the outage, because that's what they do, noting that it disrupted all traffic on TC port 443, which is the global standard port for carrying HTTPS, among other things. The group that reported that from roughly 0034 to 0148 Beijing time on Wednesday, August 20th, the Great Firewall was unconditionally injecting forged TCP RST plus ACK packets in all streams on TCP port 443, disrupting existing streams and preventing new ones from reestablishing. As a result, for that hour and a quarter, Chinese net users could not reach most websites hosted outside China or use any service utilizing standard HTTPS for transport. So, for example, both Apple and Tesla products use that port to connect to servers outside China that provide some basic platform services. My takeaway on this is a couple of things. To me, this smells like a test drive proof of concept. That's see what we can do.
What I was thinking.
The second thing is the note that both Apple and Tesla products use port 443 to connect to servers outside China. Don't do that. I don't know how to be any clearer about this, but it's been a couple years now since the Chinese issued PIPL, which is supposed to be their so-called Privacy Protection Act, but it also includes in the footnotes and fine print the fact that if you have a server outside China, anywhere outside China, that is connecting to Chinese infrastructure for any reason, Chinese authorities may decide to go scan that server and look at everything that's on it to find out, to make sure that you're protecting the privacy of Chinese nationals. That is exactly what it says. Our recommendation back at the time continues to be today. If you are, in fact, operating servers outside of China, don't do that anymore. Have a completely separate air-gapped infrastructure. If you have to duplicate services, so be it, because what you're doing is officially and actually placing your infrastructure at risk. So
your issue isn't with the port specifically, it's with having that connectivity between resources inside China and resources outside of China.
Yep. And by the way, the fact that, obviously my issue is with the Chinese shutting off the internet, but granted that they're going to do that, that's, but they have also made it very, very clear that, and it doesn't matter where your server is located. And we've had to advise clients who've said, oh, well, we're going to put our stuff in, Singapore, Australia, because it's, don't even bother. It's either all in China or it's not even touching China. Those are your options going forward. And I realize that sounds hostile, but I'm not the one that created PIPL and included the caveat that China granted to itself the right to explore all of your servers.
Yeah, based on what you've described here, this does also sound to me like it wasn't a configuration error. It does sound like a test. Yeah. So
yeah, and look at the timing of it. Come on, right? You're trying to be unnoticed if you're doing something in the middle of the night. Generally,
right.
So this is quite interesting. I'm waiting with bated breath for the gate to come crashing down sooner rather than later. We'll see. And if it doesn't happen in the next year or two, you can call me up and laugh at me. Moving right along, Lumen has just announced, actually on Tuesday, August 19th, Lumen announced that some major enhancements to its data center and cloud connectivity offerings. With a fiber connection in place, enterprises will now be able to scale Ethernet and IP services up to 400 gig across 16 highly connected metro areas and to more than 70 third-party provider data centers. Services include Ethernet and Internet on Demand, Ethernet access lines, and both point-to-point and multi-point Ethernet. Metro areas include, but are not limited to, New York City, Chicago, Atlanta, Northern Virginia / DC, LA, and Minneapolis. So it's, basically, and they claim that the goal of this, by the way, is to make sure that AI data centers have the connectivity that they need.
I was waiting for that part, yes.
Yeah, that's kind of the shoe dropping. I don't know that there's anything particularly surprising about this, but it's good to know that providers are stepping up their game when it comes to the networking.
400 gig is pretty good.
Yeah. And since no network break is complete without talking about today's or this month's favorite child, agentic AI. Agentic AI browsers are coming soon to your networks, ready to serve you phishing attacks and help you buy fake stuff. Oh. Browser extension maker Guardio says that in studying agentic AI browser Comet, they found the browser would happily do bad and dangerous things. Oh, by the way, Comet is made by Perplexity. You may recall Perplexity we reported on last week for offering to buy Chrome from Google with money it doesn't have. Always fun. For example, Comet, they set up a scam email account in Proton Mail.
This is Guardio who set up the scam email account?
Yes, Guardio, not Comet. Then sent a phishing letter pretending to be from Wells Fargo from that mailbox to the target user account. Comet swept it up, accepted it as safe, and clicked the link to a Wells Fargo login lookalike phishing page. So, gosh. In another test, they were able to give the browser agent prompts by embedding them in a CAPTCHA's page hiding instructions. The prompt provided the agent the prompt provided told the agent it could get around the CAPTCHA by clicking the provided AI bypass button, which instead initiated a malicious file download. And they got Comet to buy an Apple Watch from a fake website. And going forwards, Although the researchers explicitly directed Comet to go to that site, they said there was no barrier to Comet finding the site on its own or being directed there through malvertising, great new word, SEO poisoning, or other attacks. So the TLDR in all of this is AI browsers are just as dumb as humans. And all I can see is that, now we're going to have security awareness training for your browser.
Run that phishing test against your AI browser and see how often it fails. Yeah, so I guess the idea is then that this browser is supposed to do things on a consumer's behalf to save them the trouble of doing some clickety, buyety things.
Yeah, I'm not sure exactly why. I'll be honest, agentic AI browser is a new one for me. I try to avoid AI when I'm browsing because it generally gums up the works, as do lots of people. But I guess that's the idea is like, hey, browser, go buy me tickets to the show for whatever tonight. And you kind of hope that the tickets, the payment actually went to the show promoters and not to, some random dude.
Right. Oh, interesting. We are just heading toward more and more interesting times. All right, so we'll wrap up with some financial news. First, Fortinet, they reported financial results for their Q2 2025. The security company took in revenues of $1.63 billion, up 14% year over year, with net income of $44 million, up 16% over last year. I don't have a lot to say here. Security has been reliably revenue generating for some time, and Fortinet is carrying on here. Those are pretty good results, and they're also anticipating a good full year result looking forward. Palo Alto Networks also reported their results for Q4 and the full year. For the quarter, revenues were $2.5 billion, up 16%, with net income of $253 million. For the full year, revenues were $9.2 billion, with net income of $1.1 billion. As we talked about in a recent episode, Palo Alto Networks spent $25 billion to acquire CyberArk. We're going to have to wait until fiscal 2026 to see what the real impact of that acquisition is and how much it's contributing to Palo Alto Networks' bottom line. Any comments, Jana?
All I can say is if the Palo Alto PR people are listening to this, they're probably going, ha ha, you dinged us for overly promotional PR, but we obviously are succeeding well with whatever we're doing. Right. And I do need to acknowledge that.
We will take that comment and put it right next to that $9.2 billion we made and see which one weighs more.
Exactly.
Lastly, on Palo Alto Networks, their founder and CTO, Nir Zuk, has announced his retirement after 20 years at Palo Alto Networks. That's a pretty good run, and obviously he's leaving his baby in good shape. Myself, I give it about 6 months before he's back in business with a new startup. I think folks like this have a hard time with just sitting around doing nothing. So curious to see what his next act will be.
My guess is it's not going to be tech. Well, let's see. If it's 6 months, let's go revisit this in January and see where we are. My
guess it's going to be an AI-focused startup, just because why not? That's where all the money is. All right, that wraps up the news. Jana, where can folks get more from you?
Please hit me up at nemerdes.com. There's a contact us little click you can do, and just send me what you'd like me to know about you, and we'll be off to the races and we'll connect.
Yep, I'm Drew Conry Murray. I'm on Blue Sky at DrewCM, blogging at packetpushers.net. You can also find me on LinkedIn, and as Jana mentioned earlier, you can always hit us up with comments or corrections at packetpushers.net/FU. The FU's for follow-up. Thanks to our sponsor, Do It, and do stay tuned for our Tech Bytes podcast, where we dive into details of Palo Alto Networks' advanced DNS resolver for improved DNS security. DNS security is our topic on today's Tech Bytes podcast, sponsored by Palo Alto Networks. Specifically, Palo Alto Networks is here to talk about its advanced DNS resolver, or ADNSR, which provides a security-centric, cloud-delivered DNS resolution service. We're going to talk about how ADNSR works, its features and capabilities, and how it differs from other DNS offerings. Our guest is Rich Campagna, SVP of Products at Palo Alto Networks. Rich, welcome back to Tech Bytes. Can you give us an overview of sort of the current threat landscape, why DNS is a problem?
Yeah, well, thanks for having me again. I guess the last couple of appearances didn't go so poorly, so that I find myself here again. So I appreciate the offer to come on your show, as always. DNS is it's been around obviously since the very beginning of the internet. It's kind of core of network infrastructure and us figuring out how we're going to get to the right sites that we want to get to. So it's absolutely critical. It's also a party zone for bad actors. there are numerous ways that bad actors can leverage DNS to get to their ends. Sometimes by compromising the infrastructure itself. Sometimes by leveraging DNS to exfiltrate data outside of an organization. A number of different ways that this kind of critical part of our online experience can be compromised. And importantly, around 40% or so of organizations have absolutely no dedicated DNS security solution in place. And so, of course, attackers, like anyone else, they have a profit motive, and they're going to go after those elements of, in this case, what we're talking about today primarily is enterprise infrastructure that are, easiest to go after. And if you have, 40% of organizations leaving something open and potentially compromisable, that's where they're gonna target, right? They're gonna go after what's the minimum possible effort to get maximum possible return. And there are a number of different types of attacks that we see very commonplace in today's world. Either attacks like DNS hijacking, which is, I have a legitimate URL, and because of some misconfiguration somewhere in the DNS infrastructure, I'm gonna, as a user types that URL, let's say into their web browser, to cite a very, simple example, we're gonna send that traffic destined for that legitimate URL to a malicious IP. You may have the opposite as well, right? You sit a legitimate IP for some period of time, resolving to a well-known site or a legitimate site, let's say, and then eventually you redirect it. And so you have, situations where you have legit IPs and a malicious URL, and a legit IP, both different, flavors of different types of attacks. And then you see attackers leveraging this DNS infrastructure to do things like exfiltrate data. Right? Attackers, especially with automation and the tools we have in place today, have any amount of time to exfiltrate data. And a really convenient way to do that is in a DNS request, right? If you're able to compromise some internal asset and have that thing send DNS requests, you can dribble data outside of an organization because nobody's stopping outbound DNS requests to the outside world. So you see this data exfiltration in things like the DNS request or in HTTPS headers. That's another, sort of way. So either you're sending, users to either a bad IP or a bad URL by compromising DNS infrastructure. You are using DNS infrastructure to exfiltrate data. Any number of different types of ways that attackers have gotten creative to leverage this infrastructure. And so all the more need for an organization, to really shore up their defenses against these types of attacks.
So if I'm doing security infrastructure for DNS, what does that look like? Is it my own DNS server and I harden it magically? Do I pass everything through a DNS proxy? What should my security infrastructure for DNS look like in 2025?
So if we're talking about an enterprise type of use case, the best way to do this is to ensure that any DNS, both request and response, goes through some sort of security mechanism that's scanning those requests and responses. So, what an organization will typically do if you're working for some sort of enterprise, you have any connected device, any managed device, any device that is on your physical locations, anything connecting in via ZTNA or DNS. Typically, there's some sort of DNS resolution service that is hosted by the organization, and that's that is the kind of the ideal entry point here, because now anything that's resolving any sort of DNS request and then any response that's coming back into those assets all goes through some sort of centralized service, regardless of, let's say, where the user is or where the origination point is of the DNS request.
Well, so is that like my Active Directory infrastructure and I'm using DNS there, let's say, do I pass my DNS request through that, which is then being monitored by another service, or do I use a different resolver that's like a secure resolver service that then calls on my AD for DNS resolution?
You would use a secure resolver service then, so that all of the requests across an organization are going through some sort of service like this. It's because these things are all highly dynamic and attacks obviously not only happen in real time, but they get modified in real time as well. You need to ensure that you have this, kind of single point of DNS resolution.
Well, there's a subtle distinction here. I don't just want to watch the DNS request fly by. I actually want my security service to be the DNS resolver service for that. That's my best point to do that security work.
Yeah, absolutely. I mean, things are changing incredibly quickly. If you're letting it fly by and just kind of doing some some after the fact sort of analysis, you're going to miss a lot in terms of dynamic attacks and changes to the attack landscape. I mean, you may have a legitimate service that's hosted at a particular IP, and you've cached that lookup in your DNS infrastructure. If you're not continually refreshing that cache and looking for changes in what that's resolving to, you may have an attacker that takes advantage of the DNS infrastructure and actually redirects what was a URL going to a legitimate IP to instead a malicious IP. So you need to be constantly looking and monitoring this stuff to ensure that both in the request itself, it's an appropriate request, the response as well. Oftentimes, what we've seen more recently, and this is one of the big things that we've done in our product, that hopefully the rest of the DNS security industry follows through on, is monitoring not only the requests but the responses as well. Right. And so as organizations have gotten better with monitoring the requests. There's obviously a lot of new techniques that attackers are using there, but on the responses as well, we've seen a lot of cases of compromised DNS infrastructure where the DNS server itself has been compromised and starts serving up malicious responses. So it's important, not just, most people when they think about DNS, they think about I'm gonna check the request itself to make sure that this user is not trying to look up something that's going to resolve to some known phishing site or something as an example. And then they stop there and then they assume the response is legitimate because it's coming from inside of their organization. One of the things that we've really done that kind of differentiates the service versus what else that everything else that we see out there is this ability to scan the responses as well, because increasingly we're seeing DNS infrastructure be attacked and poisoned on the back end. And the last thing you want, of course, is your own DNS servers to be serving up some sort of malicious redirect to a malicious URL or a malicious IP. And so that's that has become really critical as well in terms of keeping pace with what attackers are doing to leverage DNS for their own ends.
So Palo Alto Networks has had DNS security capabilities, but this advanced DNS resolver is something new. So is it actually, I'm actually using then Palo Alto Networks for my DNS services, or tell me how it works.
Good point, Drew. This is not brand new for Palo Alto Networks, and DNS security is not brand new for our customers either. We've been doing this for years, implementing it in our firewalls and in our SASE solution. So there, DNS requests going through our ZTNA capabilities through the firewalls, maybe a VPN connectivity, et cetera. All that has been secured for our customers for years now, and that's where we developed this infrastructure, scanning the requests and the responses. We're scanning billions of lookups every single day. What's different is that what our customers told us was that we want to be sure that any point on our network, whether traffic is going through one of your network security solutions or not, we want to be able to provide this high efficacy DNS security service across the board, across the organization. So we've essentially taken this, what we call advanced DNS security, like that, as I said before, we've been selling for years to our customers, and basically broken it out from the firewalls and the SASE solution. So now it doesn't have to be traffic going inline through one of our systems. The entire DNS resolution for the organization gets basically pointed into this resolver service. And of course, we have a extremely high uptime and performance SLAs based on that, because now all of a sudden everything is going through this. But that's really the idea: take a service that has proven itself to be highly effective against DNS-based threats, and basically logically separate it from the inline capabilities that we push through our firewall. So the customer now has the opportunity to either use it in their firewalls and our SASE solution the way they have been for years, or use it across the entirety of the organization, whether or not traffic goes through our systems.
Well, there's two ways I can think I might implement this from an engineering perspective. I could take all of my clients and point them towards what you're describing as a cloud-based DNS resolution service. Mm-hmm. Or I could imagine I would set up a DNS forwarder for recursion from my own internal DNS service and point that at the at the cloud-based service. Is there one or the other in the way that this works, or is this an optional depending?
Right, depending on how the customer wants to deploy it. Absolutely.
Okay, so but the request is going to hit the cloud-based Palo Alto Networks DNS resolver, the ADNSR. There we go. And
you know
then
what,
I'm
Ethan,
going to
you're
get
the first one to use that acronym. Yeah. So,
well, it's right here in front of me, Rich. So I'm glad I got it right.
It's a big mouthful, but yes, the resolution, the request, and the resolution. The idea is that anything making a DNS request gets pushed through this service, and then we intermediate that on the back end to whatever other kind of upstream services are there and available.
And that service is going to know these are a bunch of bad actors that are out there on the internet. So if so you're not going to send me obviously anything that's known bad actor. You're going to have insight into all of those things, whether it's my DNS server that's serving up a bad IP address, or a client asking for a bad URL, a malicious URL, or a misspelled URL. These kind of things.
Yep. Domain squatting, we call that typically.
Yeah.
Yep.
Your server is going to detect all that and then hand back an appropriate response, whether that's off to some kind of a message web page or something like that.
Yeah, absolutely. And I'll reinforce that by saying that this is not a new service for us. This is a service already, analyzing over 1 billion new domains every single day. And including about almost 8 million new malicious domains on a regular basis. So it's already out there deployed across, millions of users, tens of thousands of customers, but now applied to a broader use case than we would have applied it before. So,
well, it's a new way to grab all that intel you've got. I don't have to punch all of this through my Palo Alto Networks firewall. I can now get it just via DNS at the DNS level.
Correct. Yes, absolutely.
Yeah, I just wanted to clarify that if I am not a Palo Alto Networks customer, I could use this service just for DNS.
Correct. Yes. Well, I hesitated on that, Drew, only because by using the service, you become a Palo Alto Networks customer.
What I'm saying is I don't need to have Palo Alto firewalls. Yeah. Okay.
Yeah, absolutely.
Okay. So it's a kind of a crowded space, maybe not a crowded space, but certainly there's a few large actors in this space. Why did Palo Alto Networks want to throw its hat into this ring competitively?
We follow our customers. In some ways, as I mentioned before, thrown our hat into the ring quite some time ago. And now we're just kind of expanding the size of our hat to take the hat analogy a little bit too far. So, what is different is that, in Palo, across our threat prevention capabilities, including DNS security, we leverage a set of technologies that we call precision AI, right? And precision AI is a massive number of investments we've made, not just in DNS, but in URL, in malware scanning, in what your viewers or your listeners, I should say, would refer to as IPS. This is a set of capabilities that takes into account all of the massive amounts of threat research that we make as a company, but then also huge huge investments in AI and machine learning to be able to just really ramp up the efficacy of any kind of threat prevention that we have across our systems. And one of the big investments over the last few years has been a move from, sort of purely inline, inside of a system, whether it's a cloud-based service or a hardware firewall on-prem, or maybe a software firewall. In the past, we were doing all these detections and building as much detection capability as possible inside of those systems. We've, over the last few years, moved those into the cloud as well. So we have the power of thousands of machine learning algorithms that are dynamically inspecting all of these things. And that's tied, of course, with a huge threat research arm that allows us to, between these things, just get unparalleled efficacy. So even in DNS security, when we had it implemented just in the firewalls and the SASE solutions, when we look at third-party head-to-head competitions, our own internal efficacy testing, what our customers are seeing us, we got it to the point where the efficacy is really unmatched, even in sort of standalone DNS security products. So that's number one. For us, we hold ourselves to an extremely high bar, even though a lot of what we build are these integrated platform-based solutions where maybe you have multiple different services implemented on something like a firewall or some other sort of form factor. The bar we hold ourselves to is that our efficacy must exceed the efficacy of anyone else, even standalone point players in the space with dedicated solutions. So that's number one, the most comprehensive coverage And we continue to see this. We continue to break ground and break news with new threats, things like DNS masquerading, malicious traffic distribution systems, which we didn't really talk about, but that's a set of tools often used by marketers to make sure that, Drew, Ethan, and I all, because we have some different characteristics, we all get different ads served up to us that are kind of more specific to our, which I think honestly is a good thing. I'd rather have an ad that's served up to me. But so what these things do is they redirect users, each of us going to the same website, may get an ad served from a different backend based on some of our unique characteristics. Well, attackers are taking these things, and we've observed them in our threat research, using these traffic distribution systems for malicious purposes to redirect us, let's say, to a phishing site instead of to a legitimate site that's serving that backend advertisement as an example. So these things are things that our threat researchers find out there in the wild, break, and of course this goes directly into our products. And maybe the other thing I'll talk about is the response inspection, right? As I mentioned before, most of the focus in the industry has been around DNS requests, right? Is this DNS request going to land this user on a known phishing site? Yes or no, right? And that's what has happened in DNS security for years. Last year, I think it was about a year, maybe a year and a half ago, we were the first and still the only major DNS security solution out there that's also inspecting the responses. And what that protects you against is the ability is the possibility of an attacker compromising your DNS infrastructure itself and then using that to serve up malicious responses. So that's another thing. Think of it as like twice as much DNS security coverage, not only the request, but the response as well. So these are the types of things. Like, we've built this strength of technology, and our customers told us time and again, we don't want to limit it just to your firewalls and your SASE solution. We want to be able to use this anywhere inside of our infrastructure. And so that's why we decided to make this expansion of that capability.
Well, Rich, we're out of time, but if folks are curious about ADNSR, what should they do? Where should they go?
Well, I believe you're going to have links in the show notes, so they can look that up there. But as always, head over to www.paloaltonetworks.com and look for ADNSR, or Advanced DNS Resolver.
All right, that is ADNSR at paloaltonetworks.com. Rich, thank you for being here, and thanks to Palo Alto Networks for being a longtime sponsor of Packet Pushers. We really appreciate that because it allows us to do what we do, which is offer high quality, deeply technical content for your professional development for free. That includes a dozen technical podcasts on networking, security, IPv6, DevOps, and more. We've also got an industry blog, 2 weekly newsletters, a community Slack group, a YouTube group, and an IRC group. You can find it all at packetpushers.net. All free, no login required. You can also hear us on Spotify, link up with us on LinkedIn, and if you would, leave us a rating on Apple Podcasts. Last but not least, remember that too much networking would never be enough.